Hello students, today we will solve numericals of chapter 1 motion, some remaining numericals. So let's solve numericals. An object has moved through a distance. Can it have zero displacement? If yes, support your answer with example. So if any object moving, then it can also have a zero displacement. It can also has a zero displacement. So here answer of this question, yes, the displacement can zero if the final position and initial position of the object are same. Let's understand with this example. Suppose that a boy is start moving from home to school, and it goes to school, and after some time boy go back their home. Then suppose that the distance between home and school is 5 kilometers. Then total distance covered by the boy equal 5 plus 5 10 kilometers. But the displacement, because initial and final position is same, then displacement becomes 0. Then an object has moved through a distance, can it have zero displacement? So yes, it have zero displacement. And next, a farmer moves along the boundary of a square field of side 10 meter in 40 seconds. What will be the magnitude of the displacement of the farmer at the end of 2 minutes and 20 seconds? So let's solve this numerical. A farmer moves along the boundary of a square field of side 10 meter. First, draw a field, square field. This is square field A, B, C and D. So let A, B, C, D is a square field of side 10 meter. A, B, C, D is a square field of side 10 meter. Then time taken to complete one round equal taken by farmer to complete one round equal 40 seconds. Total time here given that 2 minutes 20 seconds. So total time equal 2 minutes and 20 seconds. Then it's become 2 minutes change into second, 2 into 60 plus 20, it's become 140 seconds. So total time given that equal 140 seconds. So complete number of rounds equal 140 by 40. So it's become 3 into half equal 3.5 rounds. A farmer start moving from point A, and it's go to point B, B to point C, C to point D and D to point A. It complete one round, and from start A, B, C, D 2 round, and A, B, C, D 3 round, and last A, B, C. So here at point C it finished their rounds. Then total number of rounds completed by the farmer equal 3.5 rounds. So the magnitude of the AC is the magnitude. So AC vector, we have to find the AC vector. AC vector equal under root AB vector plus BC vector. Then it is 10 meter, it's also 10 meter and 10 meter and 10 meter. Because this is a square field, then it's become 10 square plus 10 square equal under root 100 plus 100 equal 200. Then it's become 10 under root 2 equal 14.1 meter. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Then find the acceleration of the bus. So let's solve. Bus decreases its speed from 80 km per hour. Then its initial velocity u equal 80 km per hour equal 80 into 5 by 18. Then it's become how much? 22.22 meter per second. And final velocity v equal 60 km per hour equals 60 into 5 by 80 meter per second equal 16.66 meter per second. Time t equal how much? 5 seconds. Then acceleration A equal final velocity minus initial velocity upon t equal final velocity how much? 16.66 minus 22.22 by 5. Then after solving, minus 5.55 by 5, it's become minus 1.11 meter per second square. So negative sign shows retardation. Negative sign shows that it shows retardation. So acceleration equal minus 1.11 meter per second square. And next, a train starting from a railway station and moving with uniform acceleration attains a speed 40 km per hour in 10 minutes. Find its acceleration. Same as solve. But here initial velocity u equal 0 and final velocity v equal 40 km per hour equal 40 into 5 by 18 equal how much? 11.11 meter per second. Time t equal 10 minutes equal 10 into 60 seconds equals 600 seconds. Then acceleration A equal v minus u by t. V, value of v here 11.11 minus 0 by 600. Then after solving, it's become 1.85 into 10 to the power minus 2 meter per second square. The acceleration of the train equal 1.85 into 10 to the power minus 2 meter per second square. Next question here. A trolley while going down an inclined plane has an acceleration of 2 centimeter per second square. What will be its velocity 3 seconds after the start? Then after the start, what will be the velocity? We have to find final velocity. Then initial velocity u equal 0 and acceleration a equal 2 centimeter per second square equal 0.02 meter per second square, and time t equal 3 seconds. Then final velocity of the trolley v equal u plus 80, then v 0 plus a 0.02 into t 3 equal 0.06 semi per second square equal 6 meter per second square. Final velocity equal. And next numerical, a racing car has uniform acceleration of 4 meter per second square. What distance will it cover in 10 seconds after the start? Then solve. A racing car has uniform acceleration. Then initial velocity u equal 0, acceleration a equal 4 meter per second square, and time t equal 10 seconds, and we have to find the distance of the car. Distance s equal we have to find. Then distance s equal ut plus half at square. When we have to find distance, then we apply second equation of motion, which is s equal ut plus half at square. Then put the value of ut, a and t from above. Then u equal 0 into t equal 10 plus 1 by 2 value of a equal 4 into value of t into 10 to the whole square. Then it's become 10 into 0 plus 2 2 is 4, 2 into 10 into 10 100, it's become 200 meter. Then distance, a racing car has uniform acceleration of 4 meter per second, then distance will it cover in 10 seconds after the start equal 200 meter. So let's solve next numerical. A stone is thrown in a vertically upward direction with a velocity of 5 meter per second. If the acceleration of the stone during its motion is 10 meter per second square in the downward direction, what will be the height attained by the stone, and how much it will take time during this? Then suppose that this is a point and a stone thrown vertically upward direction with velocity. Then solve. Initial velocity u equal 5 meter per second. Initial velocity u equal 5 meter per second, and final velocity here given that final velocity equal 0, and of the stone its motion is 10 meter per second square. Then acceleration a equal 10 meter per second square, but the direction of the acceleration to the opposite direction of the velocity. Then acceleration equal minus 10 meter per second square. Then we have to find the height when a stone is thrown upward direction, reach point B. Then according to the third equation of motion, square minus u square equal 2as. Then we have to find s or h. Then s equal v square minus u square by 2a. Then put the value of u and v and a. Then value of v equal 0 minus value of u equal 5 square by 2 into minus 10. Then it's become 5 into 5 to minus 25 by 10 to the 20. Then it's become how much? 1.25 meter. Distance equal 1.25 meter. And let's solve for time. Then time t equal v minus u by a. Then value of v equal 0, value of u equal minus 5 by value of a equal minus 10. Then it's become 5 by 10 equal 0.5 seconds. When a stone is thrown upward direction, and to reach the upward direction to point B, it take equal 0.5 seconds and travel distance 1.25 meter. So time t equal 0.5 seconds. And distance equal 1.25 meter. Numericals. Next numerical. A Joseph jogs from one end A to the other end B of a straight 300 meter road in 2 minutes in 30 seconds. 300 meter roads in 2 minutes and 30 seconds, and then turns around and jogs 10 meter back to point C in another 1 minute. What are Joseph's average speed and velocities in jogging from A to B and from B to A? So let's understand with this track, this straight line. Suppose that Joseph starts jogging from point A and it reach to point B, and then it return in point C. Then according to the question, total distance covered by Joseph A B equal 300 meter, total 300 meter, and from B to C, according to the question, from B to C 100 meter. Then we have to find the average speed and average velocity when Joseph jogs start from point A to B and point B to C. Then let's solve. Here given that BC equal 300 meter and total time taken by jogging, total time equal 2 minutes 30 seconds equal 2 into 60 plus 30. It's become 150 minutes, 150 seconds, 150 seconds. And from point B to C, then BC equal 100 meter, and time, you can suppose this is time T1 from point A to B, and from time T2 from point B to C. Then BC equal 100 meter and time T2 equal 1 minute equal 60 seconds. Then let's solve first point from point A to B. Average speed average speed equal total distance to traveled by total time taken to total distance by total time equal total distance equal 300 meter. Here given that total distance A to B 300 meter by total time T1 plus T2 equal total time equal 3 equal 150 second equal 150. It's become 2 meter per second speed, average speed. And next average velocity equal total displacement by total time taken, total displacement by total time taken equal total displacement. So from A to B equal distance equal displacement, then 300 meter by total time 150. So speed and velocity is same, 2 meter per second is 2 meter per second. And next from point A to C, next from A to C, from A to C, then average velocity, average speed equal total distance by total time, total distance equal AB plus BC by T1 plus T2. AB plus BC equal 300 plus BC equal 100 by T1 plus T2 equal 150 plus 60 second equal 400 by 210 equal 1.9 meter per second. Total speed from point A to C equal is AB plus BC. And next average velocity equal total displacement by total time, then total displacement AB minus BC, because displacement equals shortest distance between initial and final position. Then displacement AB minus BC by T1 plus T2, then AB equal 300 meter, BC equal 100 meter, 300 minus 100 equal 200 meter, 200 by T1 plus T2 210, then it's become 0.95 meter per second. So in this way, when geogebs jogs from one end A to the other end B, off is straight 3 meter road in 2 minutes 30 seconds, and then turn around and jogs 100 meter back to the point C in another minutes. What are Joseph's average speed and average velocity from A to B and from A to C? This is average speed and average velocity in both conditions when Joseph jogs from one end to other end.